section 4.1, this is substitution method. We also talked about there is a graphing method and an elimination method, which we focused on, but this one is going to be solved by using substitution. So the first thing we want to do is we have two equations, and we see that the second equation is solved for y. So we know that y equals 4x. So what we're going to do is we're going to take that value for y, we're going to substitute it into the first equation. So you're going to get x plus, instead of putting y, we're going to put 4x equals 10. And then we solve this and we get 5x equals 10. Divide both sides by 5 and x equals 2. Well, once we have our value for x, we want to go back into either one of the original and put that in and solve for y. So I'm going to take my y equals 4x, my second equation, and this time I'm going to substitute 2 in place of x, since that's what we solved it for. So you get y equals 4 times 2, y equals 8. This is the ordered pair 2, 8, which is consistent and independent. So likewise, in this next example, we're going to do the same thing. This time we know that x equals 3y, so we're going to put x in that position right there. So we have 5, and we're going to put a parenthesis. We're going to substitute in 3y, continue write the rest of equation 1 just as it appears. Now we get 15y plus 2y equals negative 17. 17y equals negative 17. And when we divide this out, we get y equals negative 1. So now we're going to go back into my x equals 3y, my second equation, which is right here, and we're going to plug negative 1 in place of y. We're going to substitute that in, so you get x equals negative 3. The solution to this one is, make sure you put your x first, then your y, negative 3, negative 1, which is also consistent and independent. Okay, we have one more problem that we're going to work, and this time equation 1 is solved for x, so I take this value and I'm going to substitute it in place of x. So then I have 2, and where x is at, I'm going to put a parenthesis and substitute that value in, then continue writing equation 2 as it appeared in the original. Distribute right there, and you're going to get 6y minus 2 minus 6y equals negative 2. Add like terms on the left, so I have a 6 and a negative 6. They cancel each other out, so I'm left with negative 2 equals negative 2. Well, when you lose your variables and you're left with this statement, you simply ask, is this true or false? This is true. That means it is infinitely many solutions. Infinitely many solutions. If it was false, we would say no solution, but infinitely many solutions. Now, a lot of times infinitely many solution is written in set builder notation, and it says any ordered pair such that, and it picks one of these equations. So I'm just going to use the first one. So x equals 3y minus 1, and then we close the brackets. So infinitely many solutions just means any ordered pair that you can find in this equation is going to make this true. So this is one of our special cases, and we said the other special case is if when we got right here we got a false statement. If you had a false statement, then we would just say false, no solution, and stop there.